Hey everyone, so in this video we're going to finish up the watermelon game. I'm going to do this one quicker than the other videos because at this point we've built up the environment. You really should be familiar with it at this point if you watch the other videos. And this is really just tidying up a couple of things. I don't think I'm going to do an optimization video. I'm not really worried about optimization in this, but I will certainly call out a couple of things that could be done better. So the two things we're going to do is A, we need to create a boundary so that the cloud can no longer go too far to the left or too far to the right. As we mentioned in the second video, all we're doing is checking for a key press. We're not actually checking for where the cloud is. So we'll add that second check for position. And then if it's beyond a certain position, then we will remove the velocity. And the second thing we're going to do is we're going to check for a game over state. We're basically just going to look to see if the fruit is too high, and that's what this object's for, and I will get to that in a minute. So let's just quickly go through this. And it's still fairly impressive that we were able to make a game with just two scripts. So that actually makes it very simple for the coding point of view. Okay, so we're in the cloud con script. And up here is where we originally put in the two checks for a key press of A or D, and then applying velocity on the x-axis depending on which key is pressed. And then we said we remove the velocity if no keys are being pressed. Okay. And then what we're going to do is this is the new code. So like I said, I'm going quicker this time. I'm not going to have you sit around and watch me type. This is the new code. So what this is doing is this is checking for velocity along the x-axis. So get component rigid body 2D velocity.x. So we're drilling down again into that x-axis and we're saying what is the velocity? Is it less than 0? And it would be less than 0 if you're holding the A key. So if the velocity is less than 0, and transform.position.x. Again, you're drilling down to x, and you're saying, is the position less than -4? Again, just because of how I set up my the boundaries for a -4, the boundaries, yours might be different. So transform.position.x, we're drilling all the way down to the x position, and we're saying, hey, is it less than -4? So if we're moving to the left and it's less than -4, then stop. And how do we stop? Get component rigid body 2D velocity equals new vector 2 0 0. So again, we're undoing what we did here. We're going to put a pin in that, and because that's one of the optimization things that I want to mention, one of the optimization points. And then rinse and repeat. If get component rigid body 2D.velocity.x is greater than 0, it'd be greater than 0 if you're holding the D key, and transform.position.x is greater than 4. See what I mean? It's really the same code a second time. You're just checking for the right control rather than the left. You're checking the right side rather than the left. And then again, get component rigid body 2D dot velocity equals new vector 2 0 0. So you're undoing what's being done here. All right. So as far as optimization, like I said, I'm not going to actually type this out, but now that we've gotten this far, you can see that this is kind of a mess. You've got you're doing all these velocity statements. Here you're applying a velocity, here you're removing the velocity. That's not great. So if I were to rewrite this, I'd probably create either a vector2 variable, or I'd create a float just for x. And in these, rather than actually applying it to velocity, I would just change the value of that variable. Change the value here and change it here, and just have at the very end a single get component rigid body that applies that variable. So, after the pluses and minuses, whatever it results to, then you do a single velocity application rather than saying apply velocity. Oh, wait a minute, never mind, get rid of it. You really don't want your code to fight each other like that. Changing a variable, that's fine because it's just a value. Here, you're actually trying to apply it to something. So in a game like this, it really doesn't make a difference. But for an optimization, you'd probably want to get rid of all these, except for one, these velocity statements, replace them with a variable. You're changing the value of the variable until you're at the end of this section of the code. So that's what you do. These are the two lines. If you want to pause the video, copy them down. But yeah, you're checking for velocity along the x-axis, checking for the position along the x-axis, and then removing the velocity, setting it to 0. Okay, so that is all it takes to control the position. So if we come in here and I now do this, see, can't go past it even if I rapidly click that button. Can't go past there even if I rapidly click that button. Okay, so hopefully that's clear. Now the next thing that we want to do is look for a game over. So there's a lot of ways to do this, and what I decided to do is I created an empty object. So this is just game object create empty. That automatically creates a transform when you create that. I added a box collider and then I edited it to make it nice and thin. And then I added a rigid body 2D. Again, these are things we've done throughout this video. Adding those to just add component, physics 2D, and then choosing them. For the rigid body, there no gravity scale. Make sure that's set to 0, and it's a trigger. Now you could ask, why is there rigid body if you don't move? Unity can be weird. Sometimes I've noticed that collisions aren't detected if there isn't a rigid body as well. I apologize, I don't know why. So sometimes a collision is detected and sometimes it's not. So you might not need the rigid body, but that's why it's there. And again, I don't know if it's me doing something wrong, but for some reason, sometimes a collision just doesn't get detected unless there's a rigid body. So I don't know if it's a bug in Unity or if it's an ID10T error on my part. So anyways, that's what we've got. So you created the empty object, you add a box collider 2D to it, that's a trigger. Add the rigid body, which like I said, you might not need. Set the gravity scale to 0 so it doesn't move. And then what we're going to do is we're going to check for when the fruit drops through this. We're going to have a timer that says, okay, don't check yet. Wait, I believe the number I use is 3/4 of a second. Wait 3/4 of a second and then check to see if you're still in this area. Because remember, there is gravity. So as soon as you hit that space button, it's dropping. So it really shouldn't be in this area too very long. So that's one of the reasons why I want this to be nice and thin and really close to the cloud so that you don't have like extra gap in there that would mess up the timing. Okay, so what does that look like from a coding point of view? Well, what I want to mention first is that I split off one thing. So actually, I think I mentioned that in the previous video, the glitch. Okay, never mind. I already did that in the last video where I split off the get key down space. I did do that. That's how we fixed the glitch with the rapid hitting of the space key. So that I already discussed. Okay, so that's good. All right, so what we want to do, we created a new variable, private string. Again, we want this to be private because we don't want it to be static. We want it to be private and we want it to be specific to every single fruit. So private string time to check equals no. And then what we do is we're going to create a new subroutine called IEnumerator check game over. Call it whatever you want, but that's what we're doing. You could call it like out of bounds, whatever. Yield return new wait for seconds. Now this, like I said, is based on how long it's going to take for that fruit to drop through the collider because we want it to pass through the collider before we check. For me, it came out to be about 3/4 of a second. It might be different for you. And then we just take that variable, time to check, and we set it to yes. So in other words, yes, we want it to check now. Okay, well, what does that do? Well, we now have this new section. As we said, this object is a trigger. So we can't check here in the pre-existing collision. This is for non-triggers. This is where the fruits are hitting each other. Okay. So private void on trigger stay. So there's on trigger enter, exit, and stay. Enter is just that, the single frame that it enters, it would be true. Exit, the single frame that it leaves, that would be true. And stay is every frame that it's happening, it's true. So on trigger stay 2D collider 2D, and as I said, it defaults to like collision, so I just changed it to other. So if other.gameObject.name equals limit, because that's why I named it here, you can call it whatever, so as long as this and this matches, because this has the collider, and we're saying we're checking for a collision with that. So we have if a collision with the trigger has occurred and continues to occur, if that object is named limit, and if time to check is equal to yes. So this might happen, or this really is happening when it's dropping through. You're having a trigger collision, but this is not set to yes yet. So all those collisions are ignored because this is not true yet. This doesn't get set to yes until, again, 3/4 of a second after you've dropped the fruit. So 3/4 of a second should be sufficient. And then really all we're going to do in this case is, if that's true, then we just do debug.log game over. So really, in the case of a watermelon game, they actually do like a freeze frame. It does a screenshot. That's a whole nother kettle of fish. Yes, there is absolutely a built-in way to Unity to do a screenshot. I don't know if it really merits it for this game, but you could do something just like that. But for now, like I said, I kind of want to wrap up this tutorial. I believe Watermelon Game is just having a moment. It's not like I'm sitting here teaching you how to make Call of Duty or something. You know, who knows if the Watermelon Game is even going to be remembered in 6 months from now. But I try to make timely content. So anyways, debug log game over. So this is a bit harder to prove. But what I'm going to do is I'll start dropping some fruit, and then I'll cut away, and then I'll wait till the pile gets higher, and then you'll see that game over appears in the debug area. So I don't think I forgot anything. I think that's it. So we added the new variable. When you hit space, we go to the new coroutine. Make sure you do this all the time. I forget to put this in. I create the coroutine and then I forget to actually call it. So when you press space, go to the coroutine. The coroutine says wait a certain amount of time. This is going to vary for you depending on how much space the fruit has to drop through. Time to check is equal to yes, and then you have this separate on trigger stay, checking to see what is the trigger that's being collided with, and if this variable has changed yet. So we'll run this. And as you can see in the lower left corner, it does not say game over. I drop it, it does not change. So that would be a problem if it's dropping through and doing game over. So that's a very good sign, the fact that it's not saying game over. So now at this point, I'm going to cut away because it's going to take a minute or two for the fruit to pile up. And then I'll come back just before it does. So I'll be right back. Okay, I actually did not cut back in time. You can see it says game over now, and basically it happened when it dropped through. Hey, I wasn't expecting the watermelon to suddenly spawn, but it does work though. So sorry about that, but it does work. I did notice a glitch, and that is this is part of the Unity system. So first of all, as you can see, the watermelon is vibrating. So like I said, I'm pretty sure the original watermelon game is made in Unity because it's got this weird physics stuff going on. Like this thing is moving in perpetuity, and it shouldn't. Second of all, sometimes I've noticed the fruits are kind of spawning inside of each other. That those the mesh collider that's being used, apparently it's a bit glitchy, and it lets the fruits like be spawned in each other. So it's certainly not perfect. There are things you'll want to do, possibly to avoid that, to do like additional checks. But again, devil's in the detail. But that's about it. So I think that's it for this tutorial. That gets you through the bulk of what you need to do. Like I said, in your game, rather than doing debug.log game over, you instead load like a high score screen or spawn text that says game over. You lock down the controls so that people can't spawn any more fruit, that kind of thing. So, but doing that kind of wrap up is really its own tutorial and not really specific to this. So again, rather than doing game over, you would actually do something like scene manager dot load scene, and you load like the high score screen or something like that. Okay, so I think that's about it. Sorry for doing this so, quickly at the end. Like I said, at this point, I think you're all familiar with the environment because you've gotten this far, and that's about it. So hopefully this was helpful. I hope you enjoyed this, and please do enjoy the rest of your day.